Hey everyone, it's Mr. Vargas here, looking to help out Math 8 today with homework assignment 7.1, Congruence and Transformations. So this comes from page 513 of the course textbook. Alright, so now in this new chapter we are going to be exploring these two words, especially with shapes. We're going to talk about congruence and similarities. And these are going to be with geometric shapes. So congruence, the word congruence, really just means that you have the same shape with the same size and the same angle measurement. So congruent or congruence means two or more shapes are exactly the same in terms of side length, number of sides, and angle. Remember, this is short for angle, shorthand notation for angle, and angle size. Okay, so pretty much we're going to be looking at different ways to have two shapes. Maybe one looks like this, and then another one looks like this. And if I was a perfect artist, these two shapes are congruent, even though this one is kind of flipped around. These two shapes are congruent because their sides are the same length, they have the same number of sides, and their angles, their little angles, are the same size as well. And we're going to be looking at different variations of that. So congruence, just remember that means it is the exact same size or shape, but maybe it's just like turned around or flipped or something like that. I'll talk about what the word similarity means in a future video, but for now let's just focus on congruence, and today we are focusing on congruence with transformations. Transformations. And if you remember, we have four types of transformations. The first one that we looked at was a reflection. Oh no, sorry, that wasn't the first one we looked at. First one we looked at was translation. Second thing we looked at was reflection. Those two were really easy. And the third one was a rotation, which just had a whole bunch of rules that told us how to rotate figures. And then the last one was dilation. Okay, so the first three are going to maintain congruence whenever we perform them on an object. So if I translate an object, that just means I'm shifting it, I'm moving it up, down, left, or right. I'm not changing the shape or the size of the object. A reflection is where we're just going to be flipping it over a line of symmetry, whether that be most commonly the y-axis, the x-axis, maybe the origin. But that also will not change the size and shape of the figure. That's just going to flip it. Rotation, remember that just means you turned the figure around about a point or a center of rotation. So that does not change the shape either. So these all three, 1, 2, and 3, maintain congruence. So shape stays same size. Now with a dilation, remember we were either shrinking or expanding a shape. So, something like this happened. We had a scalar factor, took a shape, and then we expanded it, and it looked like this. So obviously these two shapes are not the same, right? One is definitely bigger than the other. So with a dilation, we do not maintain congruence. We do not keep congruence. We do have similar figures, which we'll explore later, but we do not have congruent figures when we do a dilation. All right, let's go ahead and look at some of the problems from the homework. So I'll start out with number 2, and we've got these two shapes, and excuse my art, it's not very good, but the book has obviously much better drawings than this. Let's see, A, B, C, and this is STR. Okay, and the problem asks us to determine if the two figures are congruent by transformations. Explain your reasoning. Well, if I was a perfect artist, these two shapes are actually congruent. So I would write, yes, triangle ABC and triangle SRT are congruent. And why are they congruent? Well, what happened here? What kind of transformation did we perform on this first triangle here, ABC? All we did was just kind of rotate it, right? We just rotated it, and rotations, going back to earlier, rotations maintain congruence. So the shape did not change in size or number of sides. So yes, ABC and SRT are congruent since rotations keep congruence. Nice, that one was easy. All right, let's go to the next one. All right, I'm going to jump down to number 4 really quick. This problem has a few parts, part A, B, C, D, and E. So let's go through this together. One way to identify congruent triangles is to prove their matching sides have the same measure. Triangle CDE has vertices at 1, 4, 1, 1, and 5, 1. So CDE, and it's 1, 4, 1, 1, and 5, 1. Okay, and the first part is to just graph that, so you can go ahead and graph that. We're all pretty good at this now. Got your X and your Y, and let's see, 1, 2, 3, 4, 5. I'll do the triangle in red. 1, 4 would be right about there. 1, 1, right about here. And then 5, 1 would be right here. So we've definitely got a right triangle happening right there. Okay, and that was C, D, E. All right, find the lengths of sides of CDE. Let's zoom in. Well, from C to D, that's going to just be 1, 2, 3. So that's side length of 3. From D to E, that would be 1, 2, 3, 4. And if you remember Pythagorean theorem, to find the measurement of your hypotenuse from C to E, hypotenuse, we can use the Pythagorean theorem, a squared plus b squared equals c squared, where this missing side is going to be c. So it would be 3 squared plus 4 squared equals c squared. This would be 9 plus 16 equals c squared. And you get 25 equals c squared. Take the square root of both sides, and you get c equals 5. Okay. So this side length here is going to be 5. All right. Part C, reflect triangle CDE over the y-axis, then translate it 2 units left. Oh man, so we're going to reflect and then move 2 more left. So let's do that for each one of these points. I'm going to make this out a little bit further. Okay, so we're going to take each point, reflect it across the y-axis, with this being the y-axis going up and down. So let's move it over 1 and then 1. But since we're translating it 2 more units to the left, might as well do that right now. 1, 2. And your new point would be here. Okay, so now let's count from E to the line of reflection, the y-axis. 1, 2, 3, 4, 5. Alright, so we got to go 5 more. 1, 2, 3, 4, 5. And since we're translating it 2 to the left, let's just go 2 more to the left. 1, 2. And you get a point right about there. Okay, and then for C, we're going to go 1, 1, and 2 more. 1, 2. And our triangle ends up reflected to look like this. So this would be D prime, E prime, and C prime. Alright, so you've got your new triangle. I know my drawings aren't perfect, but it is now your job to find the lengths of, actually, step 3 says to write the coordinates. Write new coordinates, which I'm going to have you do on your own. And step 4 is to find the new lengths, find lengths of sides. Give you a hint, they're probably the same. Find lengths of new triangle. And then step 5 are the 2 triangles congruent, and tell me why or why not. Alright, and that's going to do it for this video. Good luck on the rest of your homework assignment, and we'll see you in class. Thanks.